Okay, we have considered the uncertainty or the entropy in the distribution of the outcome of 2016 vote in different countries, and how about if we divide the total population according to the total population of the countries according to which state those countries are located in, and consider the subpopulation's entropy, and take the weighted sum of this subpopulation's entropy and get the weighted sum and compare to the original one, and get some reduced uncertainty, which is the information gained by investigating the variable or the data attributes of a state. Okay, for the target of the outcome of the voting. Okay. One thing I need to note before we go from this aspect is that the statement is about the overall reduction of entropy that does not apply to individual subpopulation. For example, if you consider the state to be California, and let's look, if we execute this code, look, the entropy is higher because in California, the population of Republicans and Democrats counties are closer to each other, which, well, is consistent with the fact that the number of people voting for Republicans is fewer than the Democrats in California, and the subpopulation's entropy is higher than the original entropy. Okay. So the statement of the information gain is overall. Do not apply that to individual subpopulation. That is not guaranteed. The reduction of the entropy is not guaranteed in each subpopulation. Okay. So then let's try to consider some other aspects. For example, let's consider the education. We have some related criteria in the data frame. Let's look. Well, you have the proportion in the population receiving different degrees of education. Okay. So of course those information are related to each other, but let's just take one as example. Let's say if we can split the counties, the different counties according to how much education their residents received, and see if this can say something about their votes in 2016. I would scatter plot. Look at the scatter plot is very convenient. You provide the scatter plot, the data frame, and tell it what attribute is to use for the x-axis and what attribute is used for the y-axis, and then it will generate you a scatter plot. That's it. But of course, sometimes you need some more information. Let's show that later. Oh no, parentheses. Okay, this is scatter plot. Let's make it more informative by providing colors. See, I will say let the color to be whether Republican won 2016. When I producing this like that, it will produce a colored figure, but the color is not the same as people's usual impression that Republicans are red and Democrats are blue. So I specify the color code for those two parties. Okay, that's it. Now you have the Republicans for red. The red means Republicans won. So those are the counties where the Republicans won in 2016, and the blue dots represent counties where the Democrats won in the year. So you may say, oh look, it looks like we have some trend. So how about let's, for example, cut here. Okay, now you have the population. Here is some. It's different from here. Okay, let's see if we cut it here, whether this cut will generate a population on the left hand side, where in each county it has less than 30% of the residents receives well, bachelor's education, and on the right hand side of the county, well, there are more than 30% of the residents receives the bachelor's education. So we split it in this way, and we add one column in the data frame this way. It also gives us a warning, which I will duly ignore. So we apply very similar approach. Although it's very easy, we just need to consider two possible values, whether more than 30% of the residents receives bachelor's degree. Okay, but I would also apply the divide and conquer approach, the same approach we have used for the states. I will evaluate all the possibilities, which are true and false here, and the attributes, of course, is more than 30% bachelors, and consider the entropy of each of the subpopulation, and consider the sum, the total weights, the weighted sum, and well, I need to change that to 2 as well. Consider the information gain here. We still has the weighted sum of entropies is this, and we have information gain of this. I just copied this piece of processing from above. Okay, now you get it as some look as a routine. Okay, we can comfortably summarize this piece of processing into a function. I call that compute the information gain with respect to this attribute. Okay, let's test water on some other populations. How about let's try to look at the people. Say like what is the consequence of the population proportion of white non-Latino population and the outcome of the results. Okay, see. It seems that also that is consistent with people's impression. So let's cut somewhere. Where did I choose? Okay, I choose whether there are more than 60% of the residents are white non-Latino people. And in here, I have summarized the weighted sum and compute the difference. Well, take the weighted sum in a subroutine, and we will consider the difference. We will compute that. Just provide the subroutine the name of the attribute. Now it takes the name of the attribute and call and take out the different kind of unique values and the corresponding number of appearance of these unique values of these attributes, and to do all those computation we just introduced above. And let's do this. Okay. Where is my print? Oh, did I do that? Oh, sec. I think that's because I haven't successfully run the previous one to prepare this attribute. Now we have this attribute, and let's see. Okay, good. Wow, that looks like some piece of information which brings us more information gain. And I will invite you to read the following statement. Basically, what we want to mean is, of course, we can do some more exploratory of the data and see more of the subplot, scatter plot, and try to find all different kind of interesting attributes. Well, but one effort of machine learning, modern machine learning, is to remove the human efforts in the process. And how about let us to consider a collection of the data attributes and see whether we can get from this collection. We will try to automate the process of selecting the most valuable data attributes with respect to gain information of that. And furthermore, how about now? Look, we have considered the subpopulation of choosing one attribute, and how about to further investigate into this subpopulation using other attributes and do a finer dividend of the subpopulation, which means, look, now we split the counties into two groups. In one group, we have counties with more than 60% white population, and the other group with less than 6% white population. But how about we further subdivide the group with more than 60% white non-Latino population using the previous attribute about the degree of education the residents received. And if we have more subgroups like that, we can, this process can be applied recursively, and to we can investigate more and more attributes to get finer and finer subdivision until we have reached very much certainty about the outcome of the vote. Okay, that's the idea. That's the idea of building decision trees, and we will look at in the next video.